Oh, well, I have to finish these videos before I take you to see the president, so I guess that would be the best we could do. You're not very patient, are you? But please wait. Okay. Suppose in a college of 1,999 students, in other words, about the size of ours, one new student joins the campus and has a cold virus. We also know that 10 days later, 500 of the 2,000 have the virus. Assuming nobody is immune, estimate the number that had the virus after 15 days. Okay, interesting. So we're sure that K equals 2,000. Again, that's making the assumption that everybody is going to get the virus. Remember, that's the limiting value. There won't be any more than 2,000 that can get it. So, our K over 1 plus C, in other words, at time 0 when we start measuring this, is equal to 1. So C has to be 1999. So we've got this parameter all figured out. The only one we don't have is the B. But we know after 10 days, 500 people have the virus. So 500 goes in for the P, population of people that have the virus. And 10 goes in for the T. See, that this is kind of like an initial condition, you know, when we have this. 10 days later, 500 people have the virus, so that's an initial condition. 500 goes here, 10 goes here. But we can solve that for B, and trust me on this one, it doesn't take too long. If you multiply both sides by the denominator, divide both sides by 500, then subtract this 1, then divide both sides by 1999, then take the ln of both sides, eventually you'll get there. That B is equal to negative 1/10 times ln of 3 over 1999, which is approximately that's just the positive number, 0.6501, blah, 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 blah. I used the whole thing, don't ask me why. The negative sign is part of the formula anyway, so we didn't have to do that. So, here's the model in its complete form. Population at time t of people that have a cold virus is 2,000 over 1 plus 1999 times e to the negative, that number we found here, times t. And to find out how many have the virus after 15 days, just find p of 15. So that's not too hard. Put 15 in for that, and we discover that just about 1,782 would have the virus at that time, okay? Done differently from what you might have in a text type example, since I already figured out the solution for the model, we could actually start with the model, start with this, instead of going, solving the differential equation like from the beginning. For what it's worth, here's the graph of the function, and it's shaped a bit like a stretched out S or integral sign, as you can see, and that is the typical shape of the logistics function, which is a solution of the logistics equation. Here's the particular one we were looking at. As you can see, after about 20 days, it gets up pretty close to 2,000. Certainly by the time it gets to 25, it's very, very close to 2,000. And that is my example of use of the logistics equation giving us the logistics function. Okay, I guess I better take you to my leader now.